In 1892, Arthur Conan Doyle published a short story called Silver Blaze. It was a Sherlock Holmes story about a horse trainer who gets murdered. At a crucial junction in the mystery, Sherlock realizes that no one has mentioned about the watchdog barking. And we get this exchange. A Scotland Yard detective says, "Is there any other point to which you would wish to draw my attention?" And Holmes answers, "To the curious incident of the dog in the nighttime." Character Gregory, says, "The dog did nothing in the nighttime." Holmes says, "That was the curious incident." Aha, you see, if the perpetrator of the murder had been a stranger, the dog would have barked, but no one heard the dog barking, therefore the dog didn't bark, therefore the perpetrator was not a stranger. And I never read the story, but you get the point. The fact that the evidence was missing was itself a kind of evidence. Why are we talking about this? Well, the reason is that it's June of 2024, and there's been a lot of stories, a bit of talk lately in the media about a new report that came out that might be new evidence in the MH370 case. And this just goes to show that this, even 10 years after the disappearance, this is still very much a live case. New things, new stones are being overturned. And here's the story from the New Straits Times. The headline is "Loke. Ocean Infinity's proposal to resume MH370 search will consider new lead by UK researchers." So this is about Malaysia's Transport Minister, Anthony Loke, and he is referring to a paper published by a researcher at Cardiff University in Wales. And this researcher's name is Usama Kadri, and he works in the field of sound propagation. And he wrote a paper that was published in Nature, which is a prestigious scientific journal. The name of this paper is "Underwater Acoustic Analysis Reveals Unique Pressure Signals Associated with Aircraft Crashes in the Sea, Revisiting MH370. It's a fascinating paper, and in today's episode of Finding MH370, I want to walk you through it. I want to talk about what this paper is about, what the conclusions are that it reaches, and what it might tell us about potentially where MH370 ended up. So in a nutshell, if a plane falls into the ocean, will we expect to hear it? Or, like a dog that doesn't bark, does the absence of a sound tell us what the fate of the plane was? Hi, this is Jeff Wise. I'm a science journalist. I'm the author of the book, The Taking of MH370. You might know me from the Netflix documentary series, MH370, The Plane That Disappeared. Today, this is episode 6 of season 2, Listening for MH370. Once again, as always, if you appreciate the podcast, please subscribe, hit the like button, tell your friends. Anything you can do. We're trying to spread the message of trying to understand what happened to this very important mystery, what happened to the plane. So let's get right into it. Let me tell you this. I was planning to do part 2. Last episode was planning MH370. We looked at how the Captain Zaharie Ahmad Shah might have planned to take the plane. I was going to do planning to take MH370 Part 2, where I was going to look at how hijackers outside the cockpit might have laid their plans. Obviously, I'm not doing that today because this news happened. I want to try to respond to what's happening in the world as much as possible. And I thought this was actually a particularly interesting development. So I really wanted to jump right on it while I had the chance. So what are we talking about today? It all goes back to 1945. United States detonates the first atomic bombs. This gives rise to an arms race. Now, Russia's building bombs. China eventually starts building bombs. To test them, they detonate them. They spew radioactive contamination into the atmosphere. This is generally considered to be a bad thing. And almost from the get-go, you have a movement to stop the detonation of atomic weapons. And eventually, through many diplomatic twists and turns, you wind up with something called the Comprehensive Test Ban Treaty, which the UN kind of generates this agreement that we will stop detonating weapons, atomic weapons. In typical fashion, the United States refuses to sign on, and so the thing never actually formally goes into effect, but effectively, sort of unofficially, it does go into effect, and there is now an organization called the Comprehensive Test Ban Treaty Organization, which since 1996 has been tasked with trying to make sure that this treaty has been followed. And part of that is sniffing the air for radioactive compounds that would be produced by an explosion, listening seismically for the kind of seismic waves that would be generated by a large nuclear explosion. And a part of it is a worldwide network of 11 hydroacoustic sensors. They're basically underwater microphones. There are only 11 of them in the whole world, and yet this is considered to be enough. Why? Because sound travels really well underwater, and so if someone does detonate an atomic bomb, you will hear it at one or more of these locations. And so what we're talking about is they're usually set up in fairly remote locations, small islands. They are 3 microphones that are set up about 2 kilometers apart in a sort of equilateral triangle at a height of, a depth of between 600 and 1,200 meters. This is a part of the ocean where sound travels really well. So even though they're many thousands of miles apart, they are enough to hear any underwater detonations of A-bombs that would occur anywhere in the world's oceans. But not only that, it turns out that they're sensitive enough that they can pick up all sorts of other things too, like earthquakes and even meteor impacts. And most interestingly for our purposes today, they can detect airplane crashes. So when airplanes hit the water, they generate enough energy that they can send sound waves thousands of miles, and they can get picked up by these microphone arrays. And because these microphones are set up in triplets, the sound will arrive at, depending on the direction that the sound wave arrives from, the triad of sensors will be able to tell the direction that it's coming from. And so each sensor will record a direction and a time. And if you have 2 detections, you can triangulate and you'll be able to pinpoint where the event came from. That's the theory. Does it actually work? Well, this is why this paper from Kadri is so interesting, because basically what he set out to do was to look through the literature and find examples of planes crashing into the water and seeing how easily they were detected by the sensor network. And so let's run through what he looked at and what he found. The first diagram in the paper shows 3 crashes that occurred in the North Pacific. We have an F-35 crash that took place in 2019. This fighter plane, it was part of the Japanese armed forces, was out on a maneuver. The pilot got disoriented. He wound up crashing into the ocean at 690 miles per hour. So this is basically close to the speed of sound. This would be a big impact. And so you would expect that something like this might be detected. Sure enough, this crash was picked up by 2 sets of detectors off of Wake Island. Because these sensors are set up near islands and they want to make sure that The sound waves aren't shielded or in the shadow of the island. They generally set them up with two sets. And so we have, this is called H11N for north and H11 south. So this is the two sensor arrays at Wake Island. They both picked up the F-35 crash from a distance of 3,342 kilometers. So this basically verifies that, yeah, okay, so these hydroacoustic sensors designed to pick up atomic bomb blasts can also detect planes crashing. Another one in this image is Asiana Flight 991. This was a 2011 crash of a 747 freighter that was flying from Seoul to Shanghai, got a fire in its hold, catastrophic, led to a steep dive from 15,000 feet. Again, a pretty big impact, pretty energetic impact. This was detected also at Wake Island, an even greater distance, more than 4,000 kilometers, almost 4,500 kilometers. And finally, Transair Flight A10. This was an inter-island Hawaiian cargo flight. It lost engine power after takeoff in 2021. This was a relatively low energy impact. So basically the plane ditched and the pilot and co-pilot survived, but it was still detected at a distance of more than 3,500 kilometers. And the paper goes on. It looks at some other crashes that happened in the Indian Ocean that were detected by the sensors that are relevant for MH370. One of them is at Diego Garcia. The other sensor is at Cape Leeuwin, which is at the southwest corner of Australia. Don't know if I'm pronouncing that right. And here's some other crashes. I won't get into the details, but they detected a crash of two crashes between Madagascar and the African mainland, a distance of just over 3,000 kilometers. That was picked up just by Diego Garcia. It was not picked up by Cape Leeuwin. That would have been more like probably 10,000 kilometers or something crazy. So there is a limit to how far they can detect. But there are some other crashes that were picked up by both, notably Lion Air Flight 904. Two others, Sriwijaya Air Flight 182 and AirAsia Flight 8501, were only picked up by one of these two sensors. And the longest of these was almost 5,000 kilometers of distance. And so what we're seeing is a pretty robust result that, especially when the distances aren't too great, and especially when there isn't a lot of clutter in between, like an underwater mountain range, then you will get pretty strong signals, and you are able to detect plane crashes from a quite considerable distance. So the first part of the paper concludes that, listen, if this plane crashed into this southern Indian Ocean in the region in which it is believed to have crashed, it should, without any question, have created a detectable impact. So then the question becomes, all right, was that sound detected? Given all that we've just found out, should we expect that these hydrophones should have picked up the sound of MH370 hitting the ocean? Kadri writes, it is implausible to imagine that a significant crash of an aircraft on the ocean surface would fail to generate a discernible pressure signature, even at distant hydrophones, let alone those in closer proximity. He also writes, the official investigation of MH370 supports the conclusion that a substantial crash should have taken place near the seventh arc. In this case, the acoustic signal would have traveled approximately 1,600 kilometers to reach the nearest hydrophone station, H01 West, which is Cape Leeuwin, a considerably shorter distance than any other acoustic signal analyzed here. So of all the plane crashes he's looking at in this entire paper, MH370 would be closer to Cape Leeuwin than any other of the crashes. he writes, an aircraft with a mass of 200 tons impacting the water surface at a velocity of 200 meters per second possesses a kinetic energy of 4 gigajoules, equivalent to 956 kilograms of TNT. That is a 2,000-pound bomb. That is a large bomb. Or an earthquake of magnitude 3.2. Considering half that velocity, the release energy would still be large, equivalent to 239 kilograms of TNT. So a 500-pound bomb. That's a big bomb. Anyway, so his conclusion is, therefore, it is highly unlikely for MH370 to have crashed near the seventh arc without leaving a discernible acoustic signature. All right, this is why I was talking about the dog not barking in the night. Because if there is not an acoustic signature, that is deeply problematic. As we saw before, even a plane that didn't hit the ocean at high velocity still created a detectable signature, even at a range much greater than what we're talking about here. So if there is not a sound, that's a problem. So is there a sound? Well, there is a detection that he writes about in the second part of the paper. He writes, in summary, adhering to the official narrative, it can be asserted with confidence that if MH370 did crash in the vicinity of the seventh arc, then hydroacoustic signals should have been detected at least at H01 West, the Cape Lewin. Within the specified time window, only a single signal of interest at a bearing of 306 degrees has been identified. I should point out that there were other signals detected, but upon closer inspection, it was found that they were either in a totally wrong location or the timing just didn't plausibly match up with MH370. Because things are always happening in the ocean. There's all kinds of noise. So just because you hear something doesn't mean that it's coming from a crashing plane. It could be an underwater landslide or a container falling off a ship or God knows what. For a signal to be even a candidate for MH370, it needs to come from near the seventh arc or near the time of the final ping. So there was one that matched. However, it was only detected at one of the sites that could have picked it up. Not all three, because there were two at Diego Garcia. He writes, the only major signal has a bearing of 306.18 degrees, and it is recorded at 54 minutes past midnight UTC. In that direction, the distance of the seventh arc is about 1,586 kilometers. For an acoustic signal traveling with a speed of about 1,500 meters per second, which is the speed of sound in water, which is over 3,000 miles per hour, which is quite fast, much faster than in air. Then the required time to travel from the seventh arc to the Cape Lewin detector is about 17 and a half minutes. The time difference between the seventh arc and the time the signal was recorded is 34 and a half minutes. Thus, if the signal is associated with the aircraft crash, then there is an extra time of about 17 minutes. So there's two possibilities here. Either MH370 stayed in the air an extra 17 minutes and then crashed at the seventh arc, or it traveled for less time than that, stayed in the air less time than that, but it was traveling away from Cape Lewin, meaning back the way it had come, back towards Malaysia. Now, it's not impossible to imagine that, by the way, because if the pilot was in a death dive and then he changed his mind and he got disoriented and he really had no particular direction to be going anyway, and even if it was a ghost situation where nobody was at the controls and the plane had fallen into a bank and it might have done a few turns and then headed kind of essentially in a random direction. So it's not impossible to imagine it going away from the arc. But I basically see three problems with this detection. The first is that there's only one detection. Diego Garcia is about 3,600 kilometers from where the impact should have occurred. And there's two sensors at Diego Garcia, so one of the questions would have to be why wasn't it detected there as well? Another problem is that this is just so far north. This in the intersection between this bearing from Cape Lewin and the seventh arc is really right at the northern extremity of where Ocean Infinity conducted its search. It's really hard to justify that location based on the BTO data and the Bayesian inference method that the authorities use to derive a probabilistic distribution of the endpoints. So it's not impossible that it could get there. It's very, very statistically unlikely. So it's problematic from that perspective. And then finally, there's the issue of the timing. The timing just doesn't really match what we would expect to see if the plane had gone directly into the ocean. In episode 2.4, we went into the simulator and we looked at how the plane would have dived given the BFO values that were returned. It would have been a steep and accelerating dive. To pull out of it and then glide far from the arc seems unlikely. It's not, again, not impossible, but unlikely. And so to get as far away from the seventh arc as this image depicts it potentially going is, again, not impossible, really at the fringes of what's possible. And we've seen this again and again and again. Every time you come up with a new data set, every time you come up with a new way to look at MH370, you come up with a picture that's like, this doesn't really look like what we would expect to see. If you kind of squint and look at it sideways, you can say, okay, it's possible, but it's deeply problematic. In this case, we have three reasons why this is not what we would expect to see. Now, why was there so much excitement in the media? Well, first of all, anytime anyone says I've got new data about MH370, it tends to generate a stir. And what the author of this paper, Kadri, wound up saying was, okay, this doesn't really make a ton of sense, but we need to investigate more. We need to try to figure this out. Because if we are assuming that the plane went into the Southern Ocean, we should expect a clear signal that tells us where it went. We've seen this again and again and again with aircraft that hit the ocean. And in the case of the ARI San Juan, the Argentine submarine that went missing, they actually used this hydroacoustic data to help locate where the plane went missing. And it was really hard. A lot of people actually used that case as shedding light on MH370 because it was in a kind of underwater canyon. And when Ocean Infinity went looking for it, they missed it on the first pass because it was so deep in this canyon. And then they eventually found it. So did MH370 go into a canyon too? Well, the seabed, I think, in the southern Indian Ocean isn't quite as rugged as the Argentine coast where the submarine went missing. But more to the point, staying on topic here, we saw from the ARA San Juan detection that these sensors are very accurate between timing, triangulation, and bearing. You have a really quite accurate idea of where things are happening. The fact that we only have a single detection here and it's kind of in the wrong place suggests that maybe what we're seeing is not MH370. Again, this is just another piece of evidence, another brick in the wall. People will interpret it to fit what they want to believe. But personally, I would say that the hopes that have been raised by these recent press accounts will not ultimately bear fruit, I don't think. If you go, and as you see in this image, the author has suggested 4 places where if you set off explosions, you could calibrate and you could measure exactly how sound waves propagate in that particular stretch of ocean. It depends on salinity and temperature and obstacles in the way. Could be affected by, if it was near Antarctica, it could be affected by the ice sheet. and so forth. So yes, you could help calibrate the signal, improve its accuracy, get a clearer sense of what it's showing you. If you detonate these explosives, you might shed light on why the detectors in Diego Garcia didn't detect it. But if the claim is that this paper is bringing us one step closer to finding MH370 on the seabed of the Southern Ocean, I don't think that dog will hunt. Or to continue our initial canine metaphor, I think this is the case of a dog not barking. Well, anyway, that's all I have for you this week. Thank you once again for joining me. If you like this podcast, again, please hit like, hit subscribe. We have a show page over at findingmh370.com. If you come there, you can sign up for a weekly newsletter. You can also buy a paid subscription, which is incredibly gratifying and very helpful to help me keep this podcast going. Also, you know, give me your questions, your comments, your observations. I want to thank Keely once again for the incredible work she's been doing in sending me papers. It continues to blow my mind that after 10 years, we are still uncovering incredible new data that we're going to share with you. This case gets clearer and clearer as we find more and more information that bears on what happened to this plane. So thank you, Keely. Thank you to everyone who's contributing in all the different ways that you do. This has been episode 6 of season 2 of Finding MH370. As I like to say every week, don't stop looking and don't stop asking hard questions. Thanks very much. See you next time.